Today on Diode, I have in for a rebuild this blue laser head. Inside this blue laser head there are 8 laser diodes. Now because this is an older laser head, I expect to find either the A140 or M148 types, which can produce anywhere from 1 to 1.2 watts optically. When this was new, it could have produced anywhere from 6.5 to 7.5 watts easily, even after the losses in the optics of the laser head. Now, all laser diodes, blue in particular, will start to degrade after a while because of two main reasons. First one is oxidation of the materials that the laser semiconductor die is made out of. The second reason is electron migration, where as current is flowing through the laser junction itself, the electrons will actually grab onto atoms or molecules of the material and will drag it along. So that means instead of having nice even layers, the electrons will actually start to drag some of the portions of the layer out of position, and we'll start to get dark bands and a loss of optical power from the laser diodes themselves. So I'll be replacing the original laser diodes in here with Osram laser diodes that are 1.6 watts a piece. I'll be running them at 1.4 watts, which will give my client much longer runtime on those laser diodes. In general, it's much better for the laser diodes if you don't run them at full brightness. It's just the way it is. We should be getting about 10 watts after the build, so after the rebuild. So that's my goal. I'm going to go through the entire setup that I have here electrically, so that way you understand what I have. So you can also prepare yourself when you're doing your own rebuilds on laser heads yourself. So let's get some flying camera action. Up, 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 and away we go. Now, of course, I have the laser head right here. And we have the output aperture here. The entire laser head is on this plate. This plate is cooled by 2 thermoelectric coolers that are wedged between this plate and 2 heat sinks. And air is pulled in and keeps those heat sinks cool, and therefore the laser head cool. It's really important with laser heads that have thermoelectric coolers inside. They do get pretty warm. Over here I have some connections. So I have these right here, and that'll provide 12 volts to the laser diode drivers. And here I have my modulation connection here, which is connected to the 5-volt rail of that same power supply, which is this silver power supply right here. So my 5 volts is on this potentiometer. One side is connected to the positive, one side is connected to the negative, and the sweeper is connected to the middle. So I'll be able to adjust voltage using this potentiometer anywhere from 0 to 5 volts. That goes into here. There's another set of wires that comes off here and goes over to my multimeter, so that way I can see what my modulation voltage is exactly. And these right here are the modulation wires that go to the laser drivers. Let's go ahead and take a look at the laser drivers. We have 2 laser drivers here. This is one laser driver right here, and we have an identical one on the bottom. This whole thing looks like a home game project. That's definitely not out of a factory. It's interesting. The person who put this together did know what they were doing. However, there are some P's left on the plate. So we'll get rid of some of those. Look over the driver as well. This board right here is for the thermoelectric cooler that is inside of the laser head. Of course, we'll take a look at that later as we're going to pull the entire head apart during the rebuild. But that's pretty much all you need for the laser driver, and to power up and do your own repairs is power for the laser driver and a way to run modulation voltage, which is usually 5 volts to the laser drivers. That way you can control brightness. That's pretty much it electrically. I have my laser power meter here, which I'll be using to test the output power of the laser head as is. And I should be able to get about 10.5 watts, probably at best, after optical losses inside of the laser head, which will be much better than what we're getting right now. So let's go ahead and turn on everything. The first thing I'm going to turn on is the cooling plate. I'm going to turn that up to its full speed. I'll first turn that on. Hopefully you can still hear me. This is a pretty noisy device at this point. And I'm going to set my multimeter to volts DC. So this will be the modulation voltage that's going into the laser driver. I'm going to turn on this power supply here, which is for the laser itself. This power supply is just for the cooler. So we'll turn that on. So this is the voltage that's going to the modulation wires. We're going to see the output wattage on this indicator right here. Anything on this side of the decimal point is going to be watts, and we have tens of watts and hundreds of watts. So let's see, if it was like 1.5, that'd be 1.5 watts. So really easy to read here. I'm going to turn up the modulation voltage. We're going to see the output. So as it sets now, we're getting about 3.5 optical watts out of the laser head, which is less than half of the original power that this laser head probably had. So you can see it's a pretty thick puppy. So we're going to be pulling apart the laser head, and I'll go through the steps that you should take while rebuilding one, so that way you understand exactly what to do. Anyway, let's get into that. When you're rebuilding a laser head and replacing laser diodes like this, there's a couple of things that you should absolutely find out and note down. So the first two that we're going to note is what is the electrical configuration of the laser drivers and the laser diodes. The second one is what is the voltage and current that the laser drivers are set to. So we have two laser diode drivers right here. Each one of those laser drivers has 3 outputs. 2 outputs per laser diode driver are being used, so that means 4 outputs in total between the 2 drivers are what is supplying the current to the laser diodes. That means that we have 8 diodes here, and there will be 2 in series per output on the laser diode drivers. First thing we're going to check out is what's the voltage that we have on those laser diodes from the driver. Let's go ahead and do that. I'll turn on the laser head, turn up modulation, and we'll go ahead and get a reading. Those laser diodes that are blue normally take anywhere from 4.5 to 5 volts, roughly. We have it set on volts DC. We're going to measure that, flip it around. .26 volts. Okay, that's our voltage. Next thing we're going to do is check the current that's going to those laser diodes. So turn that off again. And for that, I'll be putting my meter in series and setting it to volts DC, or sorry, amps DC to get a reading. So this will go on the common, and this will go on the amps input of the multimeter. I'm going to take off the negative side of the laser diodes, which is right here, and then we'll be putting the meter in series with the laser diodes. Take that off. Alright. The common of the meter is going to be on the driver, and the positive is going to attach to the negative input of the laser diodes. So go ahead and put that on the driver. Just like that. And then the positive on the negative going to the laser diodes. Just like that. Make sure none of those wires are touching. We're good. Set the meter to amps DC. We're going to turn on the laser again. We're going to turn up the modulation. We're getting 1.17 amps DC, which is quite a bit of current, which means that we should be getting about 1 watt out of those laser diodes. So yeah, definitely bad laser diodes, and we're definitely going to change them out because should be getting a lot more power out of there. But now we have an idea. We know what a voltage is. We know what the current is. We'll go ahead and turn that back down. And we'll be doing a similar set of tests, especially with the current, as we recalibrate the current output of the laser drivers to match the new laser diodes. We'll get into that later on in the video. There are 2 more main things that you have to check out before replacing the laser diodes in your laser head. In order to do that, we're going to need to get inside of the laser. So undo all the screws that are holding the head on, and then carefully lift off the top of the laser head as vertically as you can, so that way you don't nick any of the optics that are on the inside. The first one is the physical size of the laser diodes, and in order to do that, you just pull off any one of the lenses on the front, and you'll be able to see the front of the laser diode. The two main types of laser diode size that you'll see are the 5.6 and 9mm laser diodes. The 5.6 is on the left and the 9mm is on the right, and you'll be able to see the front of the laser diode once the lens is off. So that's how you tell what size it is. Now these are 5.6mm laser diodes on the inside of this laser, as are the replacement laser diodes that I've got. The second thing that you'll need to find out is what is the optical polarization of the laser diodes that are inside of your laser head, and what is the optical polarization of the replacement laser diodes that you have. Well, let's take a look and see what's going on inside of the laser head here. We have our 8 laser diodes in the center. We have the knife edging mirrors on the outside, so 4 laser diodes will come out this way and reflect off this way. 4 laser diodes here on the top will go out this way and reflect off this way. We have a polarized beam splitting cube right here, and how this optic works is that anything in the horizontal polarization, which it means that the E field is going back and forth sideways, will get passed through the polarized beam splitting cube. That brings us to these laser diodes right here. So the light comes out this way, reflects off this reflecting mirror here, and goes through this optic. This is a quarter wave rotating plate. And what this does, it will change the electrical field polarization of the light by 90 degrees. So it'll change the field polarization from the horizontal to vertical. Vertical light that is going into a PBS cube will get reflected instead of just passing through, which is why we need this optic here to change the polarization characteristics. Inside of a polarized beam splitting cube, and you can see where it's in 2 pieces. So we have one triangular piece here, one triangular piece up here, and it's split from this corner to this corner and has a thin film set of optics on the inside. And that thin film will reflect anything that is in the vertically polarized light component off at 90 degrees. So the light comes in, it's horizontally polarized, hits the wave rotator plate, becomes vertically polarized, enters in the polarized beam splitting cube, and reflects off 90 degrees and out this way. So we know by this configuration that the laser diodes on the inside of this laser head are all in the horizontal polarized configuration. Now, we can also verify that with a piece of polarizing film. I'll show you how to do that. I have the E field direction already indicated on this polarizing film. We'll go ahead and turn on the laser head, see what the polarization characteristics are. Turn the cooler, turn the laser head. We're going to bring it up just a little bit so that way we get some light coming out. Little piece of paper, I'm going to put that right before the wave rotating plate. And I'm going to have this so the E field is in the horizontal. I'll put that there. And if I put this in the beam path, we're going to see that it passes through. So I'll show you that. I should switch hands. There you go. That's better. Alright, so there's our output. Here's our polarizing film. And it passes through. Now let's go ahead on the other side of the quarter wave rotating plate right here. Do the same thing. The polarizing film is at the same orientation, and it's blocked. What if we flip it like this? Now it's going to pass through, just like that. So we can already tell, as I said, all the laser diodes here are in the horizontal polarization. Go ahead and turn that down and off. Now what about their replacement laser diodes? Well, this is why I have several different models of laser diodes and laser pointers, just so I can test things like this. So I'm going to hold the polarizing film just like this. The laser diodes in my laser pointers are mounted the same way as the laser diodes in the laser head are mounted. So that means that if I pass the laser through like this, it should go through if it's the correct polarization. Let's find out. And it does. So the laser diode in here, which is the same ones that I'm going to be using to replace the laser diodes in the laser head, are the same optical polarization, which means that their size and their polarization characteristics both match the original laser diodes in the laser head. So now that we know all of the information as far as the driver characteristics, the electrical configuration, and the optical characteristics, as well as the laser diode size, we're now ready to start pulling apart the laser head and replacing the laser diodes that are inside of these brass blocks. We're going to need to pull off this brass piece. There will be screws on the bottom of the laser head that'll release that. There'll be some thermoelectric coolers that we're going to have to watch out for, and they're probably going to be full of thermal grease. But yeah, once that's all removed, there's going to be screws that are going to be holding these little brass blocks onto the plate here, and that'll free up these four. All we need to do is take out four, because once those four are taken out, we'll have access to the back of these laser hosts right here, and we'll be able to change those laser diodes out pretty easily. So that's the next step that I'm going to get into. Alright, now it's officially time for laser surgery. So what I'm going to do is I'm going to mark the rough positions of where these optics are, just as they are inside of the laser head. And that'll help me put them back where I want them, and I'm doing the alignment afterwards. So I'm going to go like this. Alright, now I'm going to remove those optics carefully, and then we'll pull off this this brass plate from the bottom. We can undo the screws on the bottom of the laser, and then we can pull off these laser hosts. So we have these three screws. We have this set of screws here that are plastic, and they're plastic because when you're clamping it together, you don't want to put too much pressure on the TECs as you're clamping it down. So looks like they prevented over clamping by using these plastic screws. And we got these in the middle. Oh, take those out. Last one, very carefully remove this one, because this is now the only thing holding that brass piece on. Flip it over. Make sure that that is now loose. Yep. Alright, now because it's probably going to be a real mess of thermal compound, put some gloves on, and we're going to clean up the thermal compound that's between the brass block right here and on the TECs. Put a spacer there so we don't get any thermal compound on the optics at all. Don't want to risk that, and it'll make a mess. So then we get to carefully pull this up and clean off the bottom of this brass plate. So that's what we're dealing with. So I'll be removing these screws right here, to be little Allen screws. So what I'll do is clean off the thermal grease, and then I'll put a piece of plastic on here, so that way if this sets back down, we get any thermal grease on there, and we'll replace that thermal grease as needed. Just like that. So now I can set this back down and not have to worry about thermal grease on the bottom getting to the side of the block that I'm working on. I'm going to go ahead and I'm going to remove all of these laser mounts. Alright, at this point now, take off the gloves. And we can take a look at the back of the laser diode blocks themselves. Get that out of the way. And each laser block will have 4 screws that clamp the diode in from behind. There's thermal grease everywhere on here. So those screws are what we need to now undo to remove the laser diode from the back. Probably clean up the thermal grease from here. That way I know that everything's clean on the top to work on and replace laser diodes. I'm going to do that, and we'll get to replacing the laser diodes. So I'm just going to go ahead and clean it up, and we'll come back. At this point, I've taken off most of the thermal grease that was on the top, so that way it won't get on my hands, therefore on the optics or anything else that I'm handling. This is the one that I'm actually going to remove first, and that's only because it's actually kind of tied up in these other wires, and I want to replace these laser diodes first. So I'm going to go ahead and remove that one, the Allen wrench, and extract that laser diode out of the host. Alright, all those back screws are now undone. Should be able to remove the back plate, get access to the laser diode, and there it is. So we'll move this off to the side. We're going to clip the wires very close to the laser diode because you want to save the length on the wires. So pull the plate down and through. Just like that, which gives us decent access to those wires. Take the side cutters and cut pretty close to the laser diode. Just like that. And that's the dead laser diode. And then I'm going to remove the heat shrink on those 2 wires and remove the back plate completely for the time being. So there's the back plate. And now we can hopefully move that out of the way. Alright, so okay. Well, at this point, now I have full access to those. So let's go ahead and start with this one, work our way down. So same thing, I'm going to remove the back plate, and then I'm going to extract the laser diode. Like that. And we can see what orientation the laser diode is in. So you'll notice that that little gold piece is up on the top. So the laser diode is mounted where the case pin is facing down in the optical assembly. So that's the same orientation that the new laser diodes are going to go in. Go ahead and clip those wires. Alright, and there's where we're going to be soldering the new laser diode on. So, one thing to note, you'll see that the positive is here, the negative is here, when you're working with lasorbs. They are, marked anode and cathode. So, you know. Let's actually test the electrical characteristics of the old laser diodes to see if they match up with the new ones. It's typically the right side with the case pin facing down is going to be positive, and the left side is going to be negative. I know that's how the Osrams are, so let's do that. Case pin is facing down, and then we have positive, negative. So just go hook it up to this lithium ion cell, see if that's what we have. Yep. So just as I thought. Alright. Now that we know that the electrical polarization is good too, it's time to put in some new laser diodes. Right. Laser diodes. So grab one out, mount it in carefully. And you don't want to touch the output window of the laser diode. You want to be very careful with these, as if you get any dust or whatnot on the output window or any fingerprints, it'll make a hot spot, ruin the output window pretty quickly, and you'll get a bad output. Oh, there's the new laser diode. Let's go ahead and install it. You're going to want to make sure that the case pin is down for most of blues like this. The case pin is in the same orientation, not necessarily down. And then we have the two other pins, which are for power. Go ahead and put this back plate on. And don't tighten it down all the way at this point, because you're going to want to make sure that the laser diode is as horizontal and as evenly put in as it can possibly be. So we want those two side pins to be on the left and the right as even as they can be, and in this case the case pin is going to be in the down position as evenly as it can be. This Allen wrench is cramping my style right now. Yeah. Okay, time for a better tool. See what I have. Bits. I don't think I have a 1mm bit. Let's see how well this works. Oh, that is so much easier. And I will go ahead and tighten it down with the Allen wrench later on, but for now, as I said, just a loose hold. Alright, let's check the orientation real quick. Now, if you see on the back of the laser diode, it's not perfectly aligned as it should be. So we're going to go ahead and give that a bit of a twist. It should rotate just a little bit. Nope, not the case friction. That's closer, but yeah. Well, what are all the tools for this project? I'm gonna have to loosen that up just a little bit more. Come on, rotate. It's close though. Alright, that looks good. Go ahead and screw it down. Now, in this particular laser diode, you don't have to worry about the case pin. So, I'm simply just going to take the case pin and press it down so it's not in our way. And that can just go wherever. So, down like that will work, leaving us with those two pins, positive on the right, negative on the left. Get some fresh heat shrink. That'll fit, right? just barely. Wait, they use some really thick wires for this. Joy. Alright, well, that's okay. Heat shrink can be expanded just a little bit. Slide over that wire. So, cut a portion of heat shrink off. Expand it a little bit. And I know it should go on the wire pretty nicely. Alright, so we got that now. We're going to have another piece of heat shrink we're going to put on there for the other side. First, I'm going to remove the extra bit of the original laser diode that was on the wire to make sure that it's not hanging out. Alright, of course not getting a heat shrink on there hot, because it's going to just contract and make my life more of a pain. Alright, now we can solder on the new laser diode, so I'm going to pre-tin both those very carefully. Just like that. And then positive and negative we'll place on. So, positive, negative. That's how it should go, from what I can tell. I just want to verify. I'm actually gonna go across the other laser orb and see if that lights up, just to make sure that the polarization of the voltage is correct. Yep. Okay. Cool. All right. Anode to anode, which is this guy right here. Cathode to the left. So let's go ahead and do that real quick. And now, slide the heat shrink over. Oh yeah. One tedious work. But they said this was light work. Stupid heat shrink. You went too far. Oh yeah, that's the gist of it. So I have to do that 8 more times, which will be fun. And then I can heat shrink all that heat shrink, and we'll get back to it once I have replaced all of the laser diodes in the laser head. We'll go ahead and test it out and see how well it runs. I tell ya, repairing a laser head like this is a lot like doing a 2 in the loo. It's much easier when you're not on camera. Alright, at this point I have all of the laser diodes on this side connected. Now I get to check to see if there's any shorts to the case. And to do that, I'll grab the multimeter. I have it in resistance, so if there's a short, you'll see that pop up on the meter. One of the leads will stay on the case here. And all the laser diodes are case isolated in this particular situation, so I should get absolutely nothing when probing the tops of the laser orbs, which are in parallel with the laser diodes. So let's go ahead and check for any kind of shorts. Nope. Nope. Looks clear. Alright, the next thing I'm going to do is to make sure that all the laser diodes are installed with the correct polarity. Now for reds and stuff like that, I can use the multimeter diode check, but since that's only about 2 volts and I need more voltage to run the laser diodes, I'm going to be using a single lithium ion cell with a 100 ohm resistor in series. And what that'll do is it'll let me test the laser diodes out at a very low current. And if they're correct, we should see just a little bit of blue light. And because we're going through 100 ohms, when I say a little bit of blue light, I mean very little bit of blue light. So let's make note, positive is going to be on the left side, negative is going to be on the right side. I'm going to go ahead and turn off the main shop light. So that way we have half a chance of seeing the little blue light that comes out. Go ahead and do that. So that one looks good. Go ahead and check the other one. That one looks good. Move over to the next. I saw that one. Oh, that one's good. Connection's bad with the there we go. Okay. So far, so good. Oh, I saw that one too. Yep. Okay, so all the laser diodes are also installed correct as far as the polarity. So now I get to put in the laser diodes on the other side. And then once those are in, what I'll do is I'll screw these brass laser blocks down, and then we'll go ahead and give it a test on the laser diode driver. But so far, it's looking good. At this point, all the new laser diodes are now installed. So I'm going to do the same test that I did before, except I'm going to test all of them now. So I'm going to go through and I'm going to make sure that there's no shorts. So let's go ahead and do that. Looks good. I'm going to also test the lower 4 in the same way that I did with the battery and the 100 ohm resistor. I'll go ahead and turn off the main shop light so we can see the blue light come out. Make sure that they're connected electrically in the proper orientation. Good. 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 Okay, awesome. Alright, at this point, I think we can actually reconnect the laser head to the driver and give it a test before I rescrew down the brass block to the laser head housing. So let's go ahead and do that. Okay, we're either going to have all the laser diodes run properly or not. So, real quick test on. Turn up the modulation just a little bit. See if they are all getting power. See, I see these blue on this side lighting up, and these blue are lighting up. It looks like all of the laser diodes are installed properly. Go ahead and turn it up a little more. Oh yeah, absolutely wonderful. Cool, that looks like it's all working well. At this point, it might look like that I'm pretty close to being done. However, that's not the case. I'm actually just about halfway. I still have to recollimate all the laser diodes. Since these are different laser diodes, they have a slightly different focal length from the collimating lens, so they're not perfectly focused. I also have to do all the alignments on the knife edge mirrors, as well as a final adjustment on this. So these will all come off and then go back on once I focus the lasers. I did not turn up the laser driver at all, but basically all I have here is set up a rough alignment just to see how much power that we're getting now. This will give me a rough idea of how much power this laser produced when it was brand new. Here's my laser power meter, same thing. So watts, and then yeah, rest of watts. You know what that means by now. So let's go ahead and turn on the laser and see what we get. Alright, what will we see? We're already up to 6.3 watts. Oh, we have already gained about 2 watts with these laser diodes. And it's not even perfectly aligned, nor is the driver turned up to the 1.4 watt range. So we still have a lot more to do. But it's getting there. It's certainly getting there. Now let's get into setting the focus of all the lasers, and each laser diode has a collimating lens in front of it, and those lenses are threaded. So in order to set the focus, we're going to need to rotate them one way or the other, and in order to do that, we need to remove the glue on the top of the collimating lenses so we can set that focus. It's very common to have glue on top of a lens instead of a laser, as it prevents the lens from moving or becoming out of alignment. So the first thing is to tackle that. I use two little homemade tools for that. One of them is just a simple little pick. The other one is a flat blade that has a sharp edge on it. These are very handy, and I suggest that you make yourself some tools if you're doing this. Now, I normally start in from the top, try to work my way out. So that's what I'll do with this one. I'll show you. Just like that. And depending on the glue that's used, this can be quite a tricky thing to do. But these little picks and stuff help when you're doing your own laser archaeology. Of course, you're going to try to avoid getting that debris on the lens. Go ahead and clear that out later, but the less it gets in there, the better. Okay, that's most of the glue off that one, and I'll go ahead and do the other lenses just like that. We'll get into how to set the focus. Now that the glue that smells like inner tubes and dog farts is removed for the most part, it's time to do our focusing. Before I get into that, I want to show you something about how lenses interact with laser diodes. Let's say we have a focused laser just like this. Well, if the lens is out too far, we'll get a convergence of the beam and a tight spot. So let me show you that. And there's our little tiny tight spot. If the lens is in too far, you won't get that. So let me show you that. And there's no tight spot. The way that the lenses are in here right now, we don't get a tight spot, so that means that the lenses have to be moved further away from the laser diodes, and that's what I'll be doing. Now, in order to do that, I have the laser shooting out this way, and there's a mirror in the back of the room which is going to reflect the beams out back towards the laser and on this white piece of material here. So I'll be able to see exactly what my beams look like on here. Now, when you're doing this, work on the laser at a low power because these lasers can be pretty bright, and Lord knows I put enough holes in shirts while doing this. So let's go ahead and turn on the laser. We're going to turn it up just to the level of where we can see those beams. Here's our output. I'm going to turn off the light. We can see how those look. And it looks like we have quite a bit of scatter here on those as well. Let's check and see what diodes those are coming from. No, not that one. Not that one. So most of the scatter seems to be coming from that one. So that lens might need cleaning. The laser diode output window might need cleaning. But let's go ahead and do the focusing now. Turn that back down. And I want to show you the tool that I'll be using to do the focusing. I made my own handy tool. This is what that tool looks like. And the tool is made from one of those eye hook bits. But the advantage is that it has an open spot in the middle, so I can't nick the lenses, and it has a wider outside, so it makes it harder for me to slip off the collimating lens as I do those adjustments. So let's go ahead and do those adjustments and see what we get with focusing those lasers. I'm going to turn off the shop light again, so that way you can see a little bit better of what I'm getting, and that way I can keep the laser on a pretty low output power. So here we go. Our first one is this one right here. You can see it's already smaller. Go ahead and do the adjustments on the other ones. Go one at a time. And take your time with this, because you don't want to nick your lenses at all. So that's that one. That's that one. Let's see what kind of output we can get on those. Okay, so looks like it's kind of an output. Probably is going to be the best we can get. It's a pretty big output. Woof. These lenses are not the best. Let's see. Well, now we know why there's anamorphic correction prisms, because definitely needs it. That's pretty good. That one we can do some adjusting on. A little more. A little more. Okay, first one is pretty good. That one's pretty good. That one's complete rubbish. I'm probably gonna have to see exactly what's making that so dirty. We'll go ahead and clean that up later on. And this one we can get a little thinner. Yeah, that one looks really rough. I don't like it. Don't like it at all. Yeah, we're gonna need to do some cleaning on those lenses. That's gonna need them. I'm gonna go ahead and do that and see what we can get as far as the output. But on some of them, you'll see how wide it is. Let me show you. A lot of laser diodes have a wide output like this, a bar. The anamorphic prism pair on the front of the laser head actually takes that and squeezes it down, so we'll get a much better beam profile than what you see here. That is just absolute rubbish right there. So, a little bit of cleanup, and that should look a lot better. So it's time to play good news, bad news. Good news. Well, the lenses are clean, and I do have them focused. Let's take a look at the output. As you might notice, it still looks like rubbish. So what's the bad news? Well, the lenses are fried. At this point, there isn't much I can do until I find new color emitting lenses for the laser. So I'm going to wrap up this video, and this will be part 1. In part 2, I'll be doing a few things. So the first thing is obviously installing new color emitting lenses inside of the laser. Whether I just get new bare lenses and install them inside of the M9 lens carriers, or get new lenses with lens carriers already on them. So those will be installed. I need to find ones that are short enough that'll allow room for the knife edging optics. The other thing I want to do is I want to take a look at the other lenses over here to see if I can find anything about how they got damaged. I have a working idea, and I want to run a few tests on these 3 lenses to see if I can figure out exactly what happened. Now, there's also a couple of things that I tried in an attempt to restore those lenses. I'll get into more of those details on what I did and my results in the next video. The other thing is I'm going to have to realign those knife edge optics, as well as these knife edge optics. They're just reflectors, and I'll get those all installed and aligned so we get a nice beam out of all those lasers. And the last thing is to set the current on the drivers. So they're currently at about 1.1 amps, and I'm going to raise them to suit the new laser diodes that I've installed. So, quite a few things to do. As I said, I'm about halfway through, but we'll save the rest for part 2. Anyway, as always, stay tuned for for more.